Hi everyone. So it's another question from the SAT College Board Study Guide with Coach Fred. So I'm looking at practice test 3, math non-calculator number 20. So if you've been following along with me, you know that we're at the last question on the non-calculator. So typically it's more of a challenging level question. I also noticed that it's wrapped up on a lot of words and I see lots going on, so I kind of need to read and see what's happening here. So it says in triangle ABC, the measure of angle B is 90, BC is 16, and AC is 20. Triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to A, B, and C respectively. And each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. What is the value of sine of F? Oh my goodness. That is just a lot of questions. So the first thing that I want to do for me is I'm going to draw these right triangles. Now, I know they're right triangles because it says that one of the angles is 90 and that they're similar. Okay. I'm going to actually make two triangles similar. I'm going to make one smaller because it says it's 1/3 the size. So we've got this triangle A, B, and C. All right, so it said that B was 90 degrees. I'm going to mark that with a 90-degree angle. And then we have triangle D, E, and F. And it said that these sides correspond to A, B, and C. So I'm going to put D, E, and F. Okay, so that tells me that angle E, if they're similar triangles have to have congruent angles. So that means that E has to be congruent. All right, so I've got some information marked. Now it says that BC, so this length is 16, and AC is 20. And it said that each side of DEF is 1/3 of the side of ABC. What is the value of sine of F? Okay, well, the bottom line is if these are similar triangles, then their side lengths are in proportion. All right, so I actually only need to find the sine of C because if two angles are similar, then their sines are going to have the same ratio. So I don't even really need this 1/3. It doesn't matter to me. But what I do need is if I want the sine of C, I need the opposite and the hypotenuse. Okay, so you have a couple options here. You could do the Pythagorean theorem. So x squared plus 16 squared equals 20 squared. Or you might recognize this as a 3, 4, 5 Pythagorean triple. That means that 4 times 4 gives me 16, 5 times 4 gives me 20 here, so then 3 times 4 would give me 12. Now, you could go through this process. You're going to get x equals 12, but you might forget what 16 squared is and what 20 squared is. So understanding those Pythagorean triples can really be helpful here. So then all I have to do is do the sine of C. Now remember, it's a ratio of the opposite leg over the hypotenuse, which would give me 12 over 20. So let's see, 4 goes into 12 3 times, 4 goes into 25 times. So the ratio would be 3/5. And that would be the sine of C and the sine of F. And again, this is only working because the triangles are right, because they're similar. And so similar means that their trig ratios will be the same. Might not be the same numbers, but their ratios will be the same. I would say that this might be a good time for you to take a second and think about the Pythagorean triples, specifically 3, 4, 5, and any multiple of 3, 4, 5. That's what we just did on this problem. 5, 12, 13. Those are numbers, integers that come up as side lengths of right triangles. 8, 15, 17, 7, 24, 25. Those are some really popular ones and really good to know for both the ACT and the SAT. All right, guys, hopefully that was a helpful video. I know it was a challenging problem, but when you think about trig, I want you to think about ratios, and that ratios have to be the same if the triangles are similar. The trig ratios would have to be the same if the triangles are similar. All right, have a great day.